So welcome once again. Welcome to lesson one, and the topic we are going to be dealing with is integrations, which are the subtopic how to integrate algebraic integral of f function f with respect to x. So from this note, firstly, before we start solving question or problem relating to integration, I would like us to know two types of integral we have, and these are indefinite integrals and definite integrals. So how can you determine or how can you differentiate between these integrals? Whenever we talk about indefinite integral, these are integral without limits. All these integrals, all the question will be given will be without limit, and you always what the final answer will always be what the antiderivative and the what and the constant c. So you will soon understand how to work on indefinite integrals and likely question possible question they are going to ask on it. So the main thing is always without what without limit, and the final solution is going to be the antiderivative plus what plus the constant c, which can take what any arbitrary value. So and like it's been mentioned here, the f of x is called the integral. That small letter f of x is a function, while the capital letter 2 is going to actually give you a function 2, which is called the antiderivative. Why c is the word is the arbitrary but constant, and that symbol symbolize what integral. It is called integral symbol. So that will now take us to what to definite integral, and these are type of integral that has what that has limit. So like example being written there is being bounded by words. Is this bounded into upper limit, which is b, and the lower limit, which is a. So and the final answer is going to be what in form of the equality, the words after the inequality, that is the square bracket into capital function, that is the derivative, and it's going to be bounded by the upper and what and the lower limit, and the final answer is going to be what f of b minus f of a. That is the function of the value of the with respect to the upper limit bound and minus what well the function of the answer gotten, that is the derivative with respect to the what to the lower limit bound. So where f of x is what is the antiderivative of the actual question actual answer we get, and the f of b and f of a is also antiderivative, are also antiderivative too, but what but with respect to the what upper limit and what lower limit. So with this, actually the first thing we are going to work on is the what indefinite integral, and you can see from that example one is a typical example of what indefinite integral, because it's what is the integral given is without what without bound. So we are asked to evaluate integral of x raised to power 2x squared dx. So how can you do this? You have been given some integral formula that in the first video that you were asked to master, and I believe you master it, because knowing this is going to soften and make our work easier, and will give you a better understanding of what we'll be doing in this video. So you can see that f of x given above is what is algebraic integral. Thus the solution will be written as what you've been given in the first slide, and that was why I put it there. You can see the integral of x raised to power n dx is equal to what x raised to power n plus 1 over n plus 1 plus c. So comparing s, you can see from the question you are being asked to evaluate, you can see that what x is raised to power 2, that means your n is going to be 2. So and what's n is going to be 2, just substitute n with 2, then you input wherever you see n, you write 2. So you apply this and you get the answer. It's very straightforward. So your finance your answer is going to be what x raised to power 2 plus 1 over 2 plus 1 plus the arbitrary constant. So which means the integration of what x squared dx is what x raised to power 3 over 3 what plus c. That is what that is the integration of that example 1. So I know you understand now. So we move to example 2. So example 2 is just like the same step with example 3, example 1. Pardon. So you see that it's not that hard. Your n, because you're asked to integrate x raised to power 3 dx, in which your n is going to be what your n is going to be 3 now. So just put, wherever you see n, just input your what? Input your 3. And you see that x raised to power 3 plus 1 all over 3 plus 1 plus c. And your final answer is going to be what? X raised to power 4 plus all over 4 plus c. That's all. So, and this example 3 is what? You are asked to evaluate a constant with a function. Both of them, you can call them a function actually. And the f of x is what? 5x ds. So once it's having a constant at the back, you bring out the constant. So you get it now. Like this note, you bring out the constant from the integral symbols, then you bring it outside. So you'll be left with what? 5 integral x ds. And you apply the normal principle. Your n is there, what? Is 1. It's invisible 1. We don't like to write any number that is being raised to power 1. So, which means 5 into bracket x raised to power 1 plus 1 over what? 1 plus 1 close bracket plus what? Plus c. And you can see at the front of that c, n is equal to what? 1. So 5 into bracket s square over 2 plus c. And we have what? 5 over 2 s square plus c. That's all. And this one, you are asked to evaluate. This is another example. This one, you need to what? Before evaluating, you need to separate them. You need to separate the value. And you can see that there is a typographical error here too. We use plus instead of minus, but I'm going to work on plus. But I will advise you should work on the minus too and find your answer. And it's not a big deal, just different in sign. So once you split, you can see this is the way you split it, assuming the sign in between x and 6 is what? Is plus. So you have what? Integral of x ds plus what? Summation of x ds. So which eventually is going to give you what? X raised to power 1 plus 1 divided by 1 plus 1 plus 6s plus c. And how to integrate a constant number as given in the first slide. That is integration formula. You can check through and convert. Once you know this, that is the basic, that is the rudiment, that is the first thing you need to know, because it's the foundation. So once you know the foundation, all the necessary things, you don't need to stress yourself, just know the foundation. It will be easier for you to tackle any integration question. So and your final answer is what? S square over 2 plus 6x plus c. So I move to example 5. And you can see that example 5, though it seems a little bit complex, but it's not. Once you understand the basic, and it's going to be well explained here, you can see that you are asked to evaluate the integral of what? 2x cubed plus 7x minus 3 close dx. So once you have this, you just split them before integrating. So you see that the first step we do what? We split all those into different function, all those function into what? Into sub-function. So which will now take us towards the integral of 2s cubed dx plus what? 7x ds plus integral of what? Plus integral of minus 3 dx. I did that intentionally for you not to confuse that. Where do we suddenly get minus 3? Actually, you need to follow that protocol stepwisely. So you can see that after that we do what? We bring out the constant, the coefficient at the back of that function. So and the coefficient at the back of s cubed is what? Is 2. We brought it out, which is 2 integral x raised to power 3 ds plus 7 integral x ds minus integral 3 dx. And with the basic you've known, with the integration formula you've been given, so you do what? You have all these answers, the antiderivative. So 2 into bracket x raised to power 3 plus 1 all over 3 plus 1 close bracket plus 7 open bracket x raised to power 1 plus 1 all over 1 plus 1 minus 3s plus c. And the answer will take us to what? 2 into bracket s raised to power 4 divided by 4 plus 7 into bracket s square divided by 2 minus 3s plus c. And you can see that we got 1 over 2 by what? By dividing the numerator and denominator by 2, which eventually will give us 1 over 2s4 plus 7 over 2s square minus 3s plus c. So, and that will be our final answer for that. So the sixth example is evaluate. This one is sum of fraction now. So how can you do that? You don't need to be frightened. You don't need to be scared. Oh, how can we solve this? It's very simple. You just look through the example given and look through the steps taken. So you see that. So you see that the first thing like we've been doing is that we bring out the constant, and the constant is this 3, which will eventually lead us to what? 3 integral what? 1 over x raised to power 4 dx. So 1 raised to power 4 dx. So recall that 1 raised to power 4 can also be written as s minus 4. That is from law of indices. Yeah. So if you don't know law of indices, you can go back to it. Actually, later on, we are going to work on that topic too. But for now, we are working on integration. So just that will now take us to what? 3 integral s raised to power minus 4 dx. Then with same principle we've been applying, we call that the integral of x raised to power n will be what? S raised to power n plus 1 all over n plus 1 plus c. So with that, you can solve what is inside that integral symbol. That is the integrand. So which is what? 3 open bracket x raised to power minus 4 plus 1 all over what? X minus 4 plus 1 plus, which is going to give us 3 open bracket s raised to power minus 3 all over minus 3 plus what? Plus c. And that is going to give us what? Minus x raised to minus 3 plus c. You'll be wondering, how are we getting minus x? That is 3 divided by 3 actually, and which is 1. You don't need to write the 1 out, you just leave it. So which is going to give you minus x raised to power minus 3 plus c. And the final answer is going to be what? Still applying indices rule, is going to be what? That is minus 1 over x raised to power 3 plus c. That is the final answer for that example 6. And we go to the last example for this lesson, for this subtopic. So you have to evaluate these two. You do what? You apply same principle. You do what? You first split this function into subfunctions, and through splitting, you can see that we have these subfunctions using the integral symbol to separate them. So you can see integral x all over square root of x ds minus integral 2 all over square root of x ds. So here too, you are going to apply law of indices to solve after splitting. So and this square root of x is going to give you what? S raised to power half. That is 1 over 2. So the same thing to the other side. So then after this, you can see that from there here, you can see that equals x. You can see that the integral x multiplied by x minus 1 over 2 dx minus integral of 2 multiplied by x raised to power minus over 2 dx. So all this is being gotten from what? From law of indices. So it's just normal law of indices, and eventually from also law of indices you add them together because they are what? Of the same base. So that will now be what? 1 minus 1 over 2, because that x is also means s raised to power 1. So you get now. So which is s1 minus 1 over 2. And we do the same thing to the other side. Actually, there's nothing to add there. So we brought out the constant here. That's why you can see the 2 outside. So after that, you simplify via fraction, and we have what? 2 x raised to power 2 minus 1 all over 2. So after solving, you have x raised to power half minus 2 all over x raised to power minus half dx. So applying the integration formula basic that I've been given in the first slide, in the first video, you have this expression which you have been acquainted with, or probably you are getting used to it actually. So solve, keep on solving, solve, and we derive at this equals to what? let me just explain the second to the last steps. So we have, after solving, we have x raised to power 3 over 2 all over 3 over 2 minus 2 x raised to power half all over half plus c. So you be imagine how we getting 2 over 3 instead of, so we having this because we are dividing x raised to power 3 over 2 divided by 3 over 2, and from what you know in division, once you want to change it to multiplication, is the sign is going to change. That is why the number change. So that is 2 over 3 x raised to power 3 over 2 3 over 2 minus 4. The same thing was done to the 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 one at the front of that negative sign too. So that is 4x raised to power half plus c. So with this, I believe you should be able to tackle any algebra function of this format actually, because there are still some complex questions to solve, but all this one are still the basic actually. So the next slide we are still going to move further into the complex aspect of algebra function, but with this I believe you're supposed to be able to tackle all small questions regarding to these examples. So let me just slide back to see the work again. If you like, you can zoom so to check properly. So see you in the next class, the next video. God bless.